Good morning, dear students. Last class, that is, in the previous class, I have given concepts and definitions of functions. That is, I have given definition of function also. When the function is forming and what is the main important concepts of functions I have told. At the same time, along with that, how we are taking a domain, codomain and codomain of the function also. Today also we'll discuss about some important concepts of functions, and today we'll discuss about images and range of the function, and how we are taking images for the function and we are taking range for the function. We'll discuss about those two today. And afterwards, I'll give you some important different kinds of functions also. In the case of constant function, identity function, polynomial function, signum function, greatest integer function, and smallest integer function, same like that we'll see different types of functions today. To all these functions, how we're finding a domain, how we're finding range, how we're finding to codomain, about all these three today we'll discuss. Now let us, we are going to discussing about images of the function now. Images means here, images of the function. Let capital A and capital B, let capital A and capital B be two non-empty sets. Be two non-empty sets. Non-empty sets. Such that such that f maps from A to B be a function, be a function, be a function, then y is equal to f of x. Y is equal to f of x is called the image of the function f. It's called image. Y is equal to f of x is called the image of the function, image of the function. This is the formula. This is the to find images of the given function here. Last lesson I have told, if you can see directly, maybe you can't understand well. If you can move through the diagrammatically easily, you can analyze everything easily here. How means I will show you now. See here, diagrammatically I am showing example for this. Example. One set A is there. It is set A and it is set B here. A to B, F is a function. Here A, B, C, D. Here 1, 2, 3, 4 like that. And A to 1 is mapping here. B to 2 take mapping here. C to 3 and D to 4. Like that we are taking mappings here. See here, image of A is 1. Image of B is 2. Image of C is 3. Image of D is 4. Like that here, images, if we can move from A to B, that is f of A is equal to 1. You consider it is x and is y. But how it will become f of x is? F of A is equal to 1. F of B is equal to 2. F of C is equal to 3. F of D is equal to 4. Like that we are collecting images. That's what I remember. I mentioned formula to find image here y is equal to f of x. See here, f of a is equal to 1, f of b is equal to 2, f of c is equal to 3, and f of d is equal to 4. Like that we are collecting images here. If you can move from B to A, pre-image. These are all the pre-image of A is pre-image of 1 is A, pre-image of 2 is B, pre-image of 3 is C, pre-image of 4 is D. That pre-image can be written by x equal to f inverse of y, like this. If y is equal to f of x, if we can write the formula, this is the formula to find images. It is the image formula. Image formula this is. But if you can go reverse like this, x is equal to f inverse of y. Like this, send f this side, it becomes inverse. F inverse of y is equal to x. This is the pre-image. Pre-image this is. Next, second we say you will see the concept and the definition of pre-image. Not now here. Today just in your syllabus just they gave only images, because if you want to find out range means must and should we need that image also. How means after completion of this definition of image and after completion of concept of image, I'll tell you about range also here. Like that. Here, images means set of all the images of the functions are 1, comma 2, comma 3, comma 4. These are all the images. How means according to this formula, we can tell about this f of a is equal to 1, f of b is equal to 2, f of c is equal to 3, and f of d is equal to 4. Like that, we are going to collecting the images of the given function here. That's what here. Images is equal to images. Images is equal to. So the elements 1, comma 2, comma 3, comma 4. Like it is the images. Next, let us will discuss about range and what is meant by range. Just now I told concept and definition of images. No. Next, let us we are going to give a definition for range. Range. Like capital A and capital B. Let capital A and capital B be two non-empty sets. Be two non-empty sets. Be two non-empty sets. Such that if F maps from A to B, if F maps from A to B is be a function, be a function, then the set of all images, set of all images, set of all images of the function, set of all images of the function, images of the function f, is called range of the function f, is called range of the function f. Function f here. Like that, we are giving a definition to this. Range of the function f here. Range means just now we found that how we are collecting the images. Same, that is range is depending upon images, and without images we can't find out range here. That's why we need first set of all images for the function f, then only we can tell easily the range of the given function f. How means I'll show with the help of some examples here. See here. First example, example 1 here. A is equal to here. Set A is equal to, you can take some elements A, B, C, D like this. And here also take some elements for set B also here. 1, 2, 3, 4 like this. 5 was no problem. A21, B21, C22 and D23. Here images A to B is one function here. Images, maybe two elements or three elements, they may have same image. Firstly, I told also, if there is repetition can be there in case of second coordinates, but we should not get repetition in case of first coordinates, I told already. When you are seeing the repetition of first coordinates in ordered pairs of given function f, easily we can tell that f is not a function. You may see that repetition of second coordinates in all types of ordered pairs, no problem. But you should not see the repetition of first coordinates in ordered pairs. That's what. Here, A and B elements of set A, they have same image in, they have same image one in the set B, no problem. Here, images. What is the images? What are the images here? Images are images. Images are 1 comma 2 comma 3 1. Therefore, range is equal to, we can write, range is equal to, we can write 1 comma 2 comma 3 like that. Maybe second example we can check here. Second example. That is A is there 1, A, B, C, D here. Here B is there, A to B is the one function, yeah. Here take some elements 1, 2, 3, 4 like this. A to 1, B to 2, C to 3, and D to 4. That's what here. Range is equal to here. Range is equal to here. One set of the elements. Set of the elements 1 comma 2 comma 3 comma 4 here. See in this function, range is 1, 2, 3. Codomain is 1, 2, 3, 4, 5. Here, range is 1, 2, 3, 4. Codomain also 1, 2, 3, 4. That's what. From these two we can tell range is always subset or equal to codomain. That's why range is always, range of the function f is always subset or directly it is equal to the codomain. Subsets or it becomes directly equal to the codomain also here. That's what here. Range is here 1, 2, 3. Codomain is 1, 2, 3, 4. That's what definitely that set of all the elements 1, 2, 3 subset to the set of all the elements 1, 2, 3, 4, 5. That's why from these two diagrams we can write range is always subset to the codomain. We can write this statement here. Range is always subset or equal to codomain. It's very important point here. Range is subset or equal to codomain. From these two diagrams, from the definition of range, we can tell is the range is always subset or equal to codomain. It is the very important point in case of solving the different types of problems in second PUC. That's what I have given two examples here. After that, with the help of those examples, easily we can realize, easily we can understood about the definition of range. At the same time, we can give one important condition is here. Range is always subsidiary equal to codomain. Now let us we are going to solving some different types of problems in the exercise 2.3. At the same time, after completion of that, I'll give you concepts of different types of functions here. Exercise 2.3. In 2.10, I mentioned some different types of questions here. Which of the following relation, number one, which of which of the following relations, which of the following relations which of the following relations or functions question mark, give reasons if it is a function, give reasons, give reasons give reasons if it is a function determine its domain and range, determine if it is a function, give reasons question mark, if it is a function determine its domain and range, its domain and range. Range. Number one, sub question. So the elements 2, 1, 5, 1, 11, 1. Next one is 14, 1 and 17, 1. Is it function or not? When you are going to checking the given relation is a function or not, already I told also, first you have to check whether the first coordinate is repeated or not. If it is not repeated means directly we can tell that that relation is always forms a function. See here, if you can observe 2, 5, 11, 14 and 17 are the first coordinates of the given relation, first coordinates of the ordered pairs of the given relation here. Already I told also, you may get repetition of second coordinates, no problem, but you should not get a repetition of first coordinates. Like that here, the relation forms a function here. How means I will show you some diagrammatically here. It is A set A, first set A can consider here, and second set B. Only single term set they gave here. 2 first coordinates 2, 5, 11, 14 and 17 here. Only first coordinate is 1 here. A to B is forming one function F here. 2 to 1, 5 to 1, 11 to 1, 14 to 1, 17 to 1 here. That's what here. Domain is 2, 5, 11, 14, 17. Range is only one single term sets. But we can't say codomain here. But it did not give whole elements here. That's why even they're asking only domain and range only. It determine its domain and range. That's why domain is the all elements of capital A, because for all x belongs to capital A, for all x belongs to capital A, then there exists a unique element of set B. That's what easily we can tell here. F forms a function. Even we can observe first coordinates, they are not repeated twice and thrice. Just maybe you may say that repetition case of second coordinates. That's what the given function here is a the given relation the given relation the given relation the given relation forms a function forms a function forms a function, and at the same time they're asking domain and range. Domain is equal to set of all first elements. What are the set of all first elements? 2 comma 5 comma 11 comma 14 comma 17. Range is equal to range range is equal to second element. What is second element? Only one element, singleton sets. Like that, we are finding domain and range. And before that, we must mention, is it function or not? I told some reasons to form a function also. You have to apply those reasons here. Next, let us we are going to moving to solve another questions. Next question is second question, sub question. 2 comma 1 comma next one is 4 comma 2 6 comma 3 6 comma 3 8 comma 4 8 comma 4 10 comma 5 next 12 comma 6 and 14 comma 7 12 comma 6 and 14 comma 7. Here also in this relation all the first coordinates of ordered pairs of this relation are different. That's why the given relation forms a function. Say first you must check them diagrammatically. You must check them diagrammatic representation. How to apply diagrammatic representation to like all these problems? Then easily we can analyze is it function or not. At the same time, easily we can analyze which is domain and which is range here. See, I will show now. It is diagrammatic representation. And here also take one more here. Here A and here B here. A to B is one function here. A is 2, 4, 6, 8, 10, 12, 14. And B is what are set of elements? 1, 2, 3, 4, 5, 6, 7. 2 to 1 and 4 to 2 they mentioned. 6 to 3. At the same time, 8 is associated with element 4. 10 is associated with 5. And 12 is associated with 6. And 14 is associated with 7. Now we are going to the elements here. F is equal to. Already I mentioned also elements. That's why for all x belongs to capital A, then there exists one unique element of set B here. I mentioned set A is the all first elements of the ordered pair. I mentioned set B is the second or set of all second elements of the ordered pairs here. Like that I have taken. That's here we can tell here domain is equal to 2, 4, 6, 8, 10, 12, 14. And range is equal to 1, 2, 3, 4, 5, 6, 7. So what now we can write here domain is equal to here. Domain is equal to let us call first elements. What are the first elements? 2, 4, 6, 8, 10, 12. That's all. Range is equal to here. Range is equal to here. Range is set of all second elements. What are second elements? 1, comma, 2, comma, 3, comma, 4, comma, 5, comma, 6, comma, 7. It is the range. Like that we are finding domain and range for the given relation capital F here. Next let us we are going to solving third question. Third question is 1 comma 3 1 comma 5 set of the elements set of our ordered pairs 1 comma 3 and next one is 1 comma 5. Next last one is the last ordered pairs 2 comma 5. Is it function or not? But the given relation does not form a function. How means? The first coordinate 1 is repeated twice here. When it is repeated twice means easily we can tell that relation does not form a function. So diagrammatically I am showing here set A here and next you write the set B elements here. Set A is 1 and 2 here. 3, 5 here. A to B is one function here. 1 to 3 and next one is 1 to 5. That's 2 to 5 here. Like this. That's why the element of the first set capital A, the element 1 of the set capital A, it contains otherwise it associated with two elements of the set B. Otherwise we can tell like this also. The element 1 of the set capital A, it contains two images. When any one element contains two or three images, we can tell the first coordinate is repeated twice or thrice. At a time we can tell that relation does not form a function. Here the element 1 having the two images 3 and 5. One have two images 3 and 5 in the case of this relation. That's what f does not form a. Otherwise, the given relation does not form a function. Should write words like this. The first coordinate repeated twice. The first coordinate. The first coordinate 1 is repeated twice in the given ordered pairs. In the given ordered pairs. In the given ordered pairs of relation. Therefore, the given relation does not forms a function, does not forms a function, does not forms a function. If it becomes function, then only we must decide about domain and range. It does not forms a function now. No need of telling, no need of expressing about domain and range of the given relation. Yeah. Now let us, we are going to solving another questions. A function f is defined by third question, second question. A function f is defined by function f is defined by f of x equal to 2x minus 5. F of x is equal to 2x minus 5. Write down the values of, write down the values of, write down the values of f of 0. First question is f of 0, and second question is f of 7, and third question is f of minus 3, f of 7, and third question is f of minus 3 here. They mentioned here f of x is 2x minus 5. That we have to find out the value of function at x equals some real number. But f of 0 becomes how much? F of 7 how much will get? F of minus how much will get? About all these things now we are going to finding their values at their indicated values. Now solution for this question is, let the given function, let the given function f of x equal to 2x minus 5 here. In this case, we are going to substituting first question is, according to first question, at x equal to 0. First question is f of 0. How we are going to finding to the function f of x equal to x minus 5. Consider f of x equal to, here we have 2x minus 5. In this case, put x equal to 0. If we can put x equal to 0, then it becomes f of 0 is equal to 2 into 0 minus 5. F of 0 is equal to 2 into 0, 0 minus 5 is equal to minus 5. Therefore, we can tell here f of 0 is equal to minus 5. It tells to us, it indicates that the value of function at x is equal to 0 is always minus 5. Here we got minus 5 over here, f of 0 is equal to minus 5 means it indicates, it shows always the value of function at x equal to 0. How much you got here? Minus plus 5. Therefore, minus 5 here is the minus 5. It is the value of the function at x equal to 0. That is f of 0 is equal to minus 5. Next, similarly, same way, we are going to finding the value of function at x equal to 7 and the value of the function at x equal to minus 3 here. Second question. F of 7. F of 7 here. Let the given function consider f of x equal to x minus 5. In this case, put x equal to 7. Put x equal to 7. Then we can tell f of 7 is equal to 2 into 7 minus 5. F of 7 is equal to 2 into 7, 14 minus 5 here. F of 7 is equal to 14 minus 5 is 9. Therefore, 9 is the value of function or function value at x equal to 7. Directly you can substitute means that is the function value. Not only here, if you can put any value directly in place of variable of any function, we are getting some value now. That value is always called as the function value at x equal to some indicated value here. So let us, we are going to find one more value minus 3 here. Third question. F of minus 3 here. F of x equal to here 2x minus 5. In this case, put x equal to minus 3. Put x equal to minus 3 here. F of minus 3 is equal to 2 of minus 3 and minus 5 here. That is equal to plus into minus 6 minus 5 is equal to minus 11. It is equal to f of minus 3 value. That is f of minus 3 is equal to minus 11. It shows that the value of the function at x equal to minus 3 is always minus 11. Therefore, we have done here f of minus is equal to minus 11. Like that today, I told the concepts of a function and I told the concepts of images and concepts of range. At the same time, which types of relations are forming functions, about that also we discussed today. And how to find out the value of the function at indicate some real numbers. About that also just now we discussed 3 questions and we solved them also here. But next class onwards, how to find out the domain and range of the given function. How we are going to find a domain and how we are going to finding range for the real valued functions. What is meant by real valued functions means a function having domain is set of all real numbers and range is set of all real numbers and codomain is set of all real numbers, then we are calling those types of functions are called real valued functions. To those real valued functions, how we are going to finding domain and how we are going to finding range and how we are going to finding codomain, about all these next class we will discuss. At the same time, after completion of all this, we will discuss about domain, codomain and range of different types of functions also. We will do like all these things from next class onwards. Thank you very much.